we're doing our mapping technique. This is a little bit different to yesterday. We don't have the sled or the high-def camera that we're dragging on the boat, so we're doing some duck diving, we're grabbing samples, we're estimating primary and secondary species. But, Dr. Maxwell, what did we come up with?
So you've got two different species here. You've got this one here, which is what we call eelgrass. It's a Zostera mulleri, which you find all over the place, down the east coast of Australia, down into Victoria and South Australia as well. This guy is found all across the bay, and you can see how he's quite tolerant of dirty water, which is always good. Then we've got this one, which is what's called dugong grass. So the dugongs love this guy. All the nutrients are in the leaves. He's a bit of a weedy species, so he likes to opportunistically grow, and then he'll die out very quickly after that when the conditions get poorer. So he's got a lower tolerance, but will grow anywhere, essentially, very quickly.
Hey, I've got one question about this. So the Zostera, we actually have this in Williamstown, where our school is. Right. We've got very different conditions. The water's obviously a lot colder. And the kids at the moment are learning about ecology and factors that contribute to the success of a species.
Okay.
What makes this species so successful that can live here and in Victoria?
So this guy is a really clever little seagrass species. So what he can do, he can adapt to a wide range of different water qualities. So you can see how turbid it is here. So what they do is essentially they grow a longer leaf, a thicker leaf, and they'll put on more chlorophyll, which means that they're able to capture a lot more light in the lower turbidity, or the lower light water with high turbidity. When we go over towards the eastern part of the bay, where we were yesterday, it's a much finer species. So it's the same species, but it's a much finer leaf. They don't have to capture as much light because there's so much more light in the available to them, which means they can invest a lot more heavily in this stuff, in the below ground biomass, in these rhizomes, which are between the shoots. So you see here the rhizomes between the shoots, that's where they store their energy. It's a little bit like your liver. So all the starches and all the sugars are stored within these rhizome matters, and when the water gets so turbid like it does today, they can rely on those sugars. They can rely on those sugars to get them through the bad times. So this is a really tolerant species with poor conditions. They're quite an opportunistic seagrass species, which means they can live anywhere they like.
Fantastic. Now I just heard the radio call for you, so you better get going.
Yep.
Thank you.